Unit-to-unit conversion. So this is an important part of science and especially chemistry, because converting from unit to unit is very important so that we can compare and do experiments. So there are two systems of measurement, two main systems. The American system, which is unique to the United States. This system of measurement was developed from British imperial units. So for example, pounds, which is the name of money also in Britain. So pounds, inches, gallons, all of those are specifically unique to the United States. So we use them as measurements that are common here. But in science, we use the global system of measurement, or SI units, metric system, so that we use a metric system which is based on powers of 10. So some examples are a kilogram. 1 kilogram equals 1,000 grams. Kilo stands for 1,000. And centimeter, 100 centimeters equals 1 meter. So centi means it's going to be actually a representation that you need 100 of whatever centis. You need 100 of it to make 1 meter or 1 gram or whatever. So all these things are important because converting between the system with base of power of 10 is very easy, because all you have to do is move a decimal point, the specific number of powers of 10. So sort of like scientific notation. So the metric system we can convert in. We have to be able to convert in within the American system, but most of all we have to be able to convert between the American system and the metric system. So if something is measured in the American system that we need to be put into a metric system, we have to be able to convert that so that we can use it for later reference in experiments. So mixed units. The SI base units, the ones for the metric system, so the international system of units, that's why we call it SI base units. You might notice that it says SI instead of IS, because you see international system of units, but it comes from the French système international. Okay, so in French actually this system comes before international, so that's why it's SI base units. Has 7 base units that serve as the measurements from which other units are derived. So the reason we can look at other units is because we have these base units that measure what is going on. For example, we have a physical quantity, length. The base unit is the meter, and its abbreviation is m. Mass, we have the base unit kilogram, and the abbreviation is kilogram. Time, we have second, and S is the abbreviation. Electric current, we call it an ampere, and A is the abbreviation of capitalized A. Kelvin for temperature, and we use K. Luminosity, we use a candela, which we put as CD, and for an amount, we use mole, and that abbreviation is MOL. So these units, we can use them to derive other mixed units when we do things that involve length and mass and the relationships between things that are between length and time or things like that. We can use these units as the base units to form mixed units. So remember that we have two systems, the American system and the international system, or the metric system, and these have base units, or the international system of units, that has 7 base units and serve as measurements from which other units can be derived. And units are very important because they let us know whether we're talking about length, mass, time, electric current, or temperature. And we don't want the numbers that we're floating around to be misread as mass when they're supposed to be read as length. So be careful with your units. Make sure you write them. Make sure you understand what they mean, so that when you do problems, you know exactly what to look for and exactly what's important for you to use.